Okay, so we're going to go to example number 1, and we're going to see just how this works out in your assignment. It's really not that bad, thankfully. It just says replace each, and this is page 94, replace each blank with less than, greater than, or equal to make each sentence true. So you have A, negative 75 compared to 13. All right, I'll give a couple of the places where people get mixed up, but I'll help you out with this one. What's the comparison symbol? Anybody? Less than. And on the number line, negative 75 is way out here. 13's over here, so it's less than. And I'm just going to give you a hint right now. Any negative number is always less than any positive number. Okay, no matter what negative and positive you're talking about, any negative is always less than any positive. Okay, B. B is comparing negative 14 and negative 22 plus 9. Okay, so you're comparing those two expressions. Negative 14 is easy to think of. What is negative 22 plus 9? Negative 13. So that's kind of a review of your adding and subtracting integers. So what's the comparison symbol here? And that's no. Listen, that's exactly what I was going to come up. Listen to my question. Isn't 14 bigger than 13?
Negative 14.
Yeah, but negative 14 is smaller than negative 13, so negative 14 is less than negative 13. Again, negative 14 would be somewhere over here. Negative 13 would be right here. So negative 14 is less than negative 13, and that's a common place. No, don't feel bad. It's very easy to get that. Okay, and then 3/8 compared to negative 7/8. 3/8 compared to negative 7/8. Greater. Whoa. Wait. Hold on. Let me do this real quick to check it. 3/8 negative 7/8. Yes, you're correct. Okay, how do you know that without even looking at those fractions? Really? I hope you know it. Margot?
It's negative. The front of the right negative.
So any positive is greater than any negative. Remember how I told you any negative is less than any positive? So the reverse has to be true. So yeah, it'd be greater than. Okay. Wouldn't it be nice if all your fractional comparison problems had common denominators? Because all you have to really compare is the numerator together. But are all the problems going to be like that? No, you can sigh in disbelief. But unfortunately, no. So example number 2, these are the problems that you will have to do as well. And they're not as straightforward always as the ones we just did. So example 2, A, 7/13 compared to 4/15. Guys, there are multiple ways to work these problems out. We looked at last year a few ways of doing it, but here's a way you can always do it, and you can always get it right. Okay? So here's the way to do it, and make sure I have the correct signs. Okay. Is 7/13 greater than or less than or equal to 4/15? I don't know. So what I'm going to do is this. I'm going to cross multiply. Do you guys remember cross multiplication? So what I'm going to do, 7 times 15, and then 13 times 4. So what's 7 times 15? 105. Good job. And then 13 times 4, 52. Okay, what's the comparison symbol between these two? What would it be between just these two numbers? Greater than. You know what the comparison symbol up here is? Greater than. That's your answer. Yep, always works that way. Now, let me get your question just a moment. It has to work this way. The numerator of the first times the denominator of the second. That's right here, right? And then the denominator of the first times the numerator of the second. That goes right here. If you switch them around, you would have gotten the less than symbol, and then you'd have to flip it to the greater than. So please just do it the way I did it. This times this, and then this times that. There are other ways, but go ahead. Yeah, what is it?
Yeah, for this problem, if you look at the fraction and the denominator is relative, if the numerator is higher and the denominator is lower, then the fraction is not bigger.
I know what he's saying.
And here's, it's what we call a number sense. Some of you can look at the numbers and like, okay, I kind of get what that is, and yep, okay, I know what the comparison symbol is. One way would be comparing it to 1/2 and 0 and 1. Do you guys remember that? You round it to 0, 1/2, or 1. What would this be rounded to? 1/2. And then this one would be rounded or go in between 0 and 1/2. So this one's smaller than that one. I mean, you could see that. This is a little bit bigger. This is smaller than 1/2, and therefore you can see it without doing the cross products. But, Walker, after this question, they're not this straightforward, even with those problems. Go ahead. You have a question?
So, why wouldn't you do like 13 times, well, maybe, let's say you did like, you did the cross multiplication, but then you put like 52 on the other side. Why do you put
Like you did 52 and 105? No, you could do that, but wouldn't it be 52 is less than 105? And then that would be, is 7/13 less than 4/15? No, you just have to do it a certain way to make sure it matches what your problem is. I mean, you could do that, but then you're going to switch the sign. All right, here's the problem where I'm thinking of, oh man, really? Those are really close. They are. They're very, very close. A number sense would be this. This is 1/8 from 1, and this is 1/9 from 1. Some of you are saying, so what? Okay, if you don't get that, what I just said, cross multiply. What's 7 times 9? 63. Good. What's 8 times 8? Okay, what's the comparison symbol here? Less than. So the comparison symbol is that. Less than. There you go. Less than. Yeah, it's very close. 1/8 and 1/9 are very close. In fact, we're going to talk about like distances for numbers in just a bit. Questions on that? You guys know how to compare it? You can use cross multiplication every time and get it right, but there are other ways to do it. Just whatever's more comfortable. Yes, sir.
That problem is sort of like in basketball. If you, after the free throw percentage, if you make one, then you go 7/8, 7/8 to 8/9. That makes it better.
Yeah, oh, great point. If you were 7 for 8, you've made 7 out of 8, and then you make your next one, shouldn't your average go up? And it would go up to 8 over 9, 8 for 9. Yeah, great. Good way of thinking it. Good use of basketball, too. Bonus point, Hayes.
Yeah.
Buffalo Wild Wings for you. Okay, anyway, example number 3. This is, depending on my time, example 3 we're definitely going to do. Can someone read that for me, please? Example 3. And read it with enthusiasm, because look what it says in there. Margot?
Use your brain.
Oh, bonus points, Margot. You must have the updated edition, but go ahead. Use your brain.
To write the fractions 3/8, 4/5, and 1/6 as decimals. Then write the fractions in order from least to greatest.
Okay, you're doing two things. You're writing those fractions as decimals, and you're ordering from least to greatest. So I'll see if you were paying attention, but yes, use the brain that the Lord has given you. But Mr. A, I struggle with that. That's okay. Let's get better by practice. Yes. And you can revolt against me after I turn Swivl off, just to keep it family friendly here. All right. 3/8 and 4/5 and 1/6. Okay. How in the world do I turn these into decimals? I don't know. You divide. Okay. 3 divided by 8. 4 divided by 5. What do you think so far? So far, so good?
The way you want one.
And 6 divided by 1.
Hold up. You messed up on that.
Help me out here, guys. I'm confused. All right. Is this the correct way to show the division on 3/8?
Yes.
Is this the correct for 4/5? Is that the correct for... Ooh, guys, what's the rule when you're turning a fraction into a decimal? You always put this in the box, and you always put this outside the box. What is that? This and that. Hayes? The numerator is always in the box, and the denominator is always outside the box. No matter what fraction you're talking about, I don't care what numbers these are, that's always the way you do it. Do you understand me?
Yes.
Good. Go ahead and find them out.
Good.
Don't forget, guys, you obviously know that 8 doesn't go into 3. but it does go into 30, but you need to put that decimal point where it belongs. And you're going to realize that for all of them. Wow, some of you did them really quickly. That's amazing. I might give you some bonus ones to do in your head. Try to work them out. I just want you to get practice with them because they're not always that easy as you've already experienced in your lifetime. Okay, what is 3/8 as a decimal number? Somebody raise your hand, tell me, Benson. 0.375. That is correct. Or 0.375. All right, what's 4/5 as a decimal number? Beth? 0.8 is correct. And then 1/6 as a decimal in proper format. Eli? Sorry, go ahead. 0.6. Close. Josh?
0.16.
0.16. The 6 is repeating. Those are the... Oh, nice. Ta-da! Sorry, I got to circle them. What's wrong? What's wrong? These are the... Please follow the instructions. They're going to tell you write them as fractions and or decimals and then do the second step. So which one would come first in this problem? Which is the least number out of these three? Yes, sir? 0.16 with the bar. Second number would be, I know Benton knows. Wyatt? 0.3, wow. 0.375, and then last number would have to be 0.8. Okay, so you write those in order. Don't forget to do that. Okay. Tornadoes. They're more than just an annoyance sometimes, aren't they? Okay. Oh my. Okay, anyway, the drills. Let's do one more property. And this was a cool one, the density property. The density property. Oh, this is cool. You want a little bit of science today? Of course you do. Okay, do you guys remember what density means in science? Does anyone know what density is? Yeah.
Probably these kids define it better.
Okay, you can give an example or...
I don't know how to explain it. Let me answer.
Yeah.
The more weight per area, then the more dense.
Okay, here's a simple example, guys. You know how things float on water and things sink in water? And it's based on the object's density. So when I see like a leaf floating on the water, why doesn't it just sink to the bottom of the water? Because the density of the leaf is less than the density of the water, right? That means that the mass in the leaf is less compact. Why does a rock fall into the water then?
It's really compact.
And it's really dense, we call it, right? Good. By the way, helium balloons, why do they rise above the air? Because helium is less dense than the air and different compounds in the air. So technically, if I were less dense than air, guess what would happen to me?
Oh no.
I would have a fun time. But I would be kind of mad because I can't do anything I really want to do after a while. I'm just floating around getting pushed by everything. It's a hard life. Okay, anyway, yeah. As you guys start getting into that. It's the same idea. It's how much stuff you can fit in between numbers. Okay? So the density property on page 96. Vivian, can you read the density property for rational numbers?
Between every pair of distinct rational numbers, there are
Infinitely? Yeah, that's a tough one.
many rational numbers.
Whoa. Okay. Between. Oh, that's terrible. Between any two rational numbers, there are an infinite, and I'm saying it's slightly different, an infinite number of of rational numbers. That's a mouthful. Okay. I'm going to use the number line again to demonstrate it. Excuse me. There are an infinite number of rational numbers. And then I go, okay, let me just show you what that means. We still have 2 minutes because the bells are off. But let me just finish this off. 1/2 and 3/4 are two rational numbers. Are you guys good with that? How many numbers are in between 1/2 and 3/4 that are rational? Okay, ready? I'm going to show you as many as I can. And you keep going, and you keep going. Oh, I missed some of them. Okay, multiply that by 1,000,000, and then you haven't even come close. Which is kind of sad, and yet kind of impressive. Can you find the number that's right in between the two? Right in between. Do you know how to do it? It's simple. If this were 1 and 3, how would you find the number in between 1 and 3? Do you remember what we call that little? It's a the average of two numbers.
The mean.
The mean is right in between. What is the average of 1/2 and 3/4, or what's that number right in the middle? Do you know what it is? Well, all you have to do is 1/2 plus 3/4, and then multiply or divide. You got to multiply by 1/2 or divide by 2. That would give you the number right in the middle of the two. And you can do that with any two rational numbers. You can find the dead center, and you know what? You can find the number between these two, and then these two, and then those two, and then. Okay, Swivl, we need to pause.